Now we have discussion about, first of all, what is the ferrite and what is the property of these ferrite materials, as well as we'll see the Faraday rotation, and later we'll see followed by the circulators and isolators. We'll see that how circulator is going to work with the help of ports. We'll take examples, and again very important, how isolators is going to act as the isolators, how it's going to absorb the reflected wave. All these things we are going to see with the help of S matrix of the circulators. So still, if you didn't subscribe our channel, please subscribe it and share with your friends. So previous lecture we have about this two-hole directional couplers. So that is also available. So there you have seen that how it is transfer takes place from the port 1 to port 2, all these things. Okay. So let's see about circulator and isolators. And before that, we need to know which type of the materials we are going to use and how it is going to work. So here we have non-reciprocal transmission device. Okay. So these two are the non-reciprocal device, and it is based upon the property of the Faraday rotation. So here might you will have separate question also about, write about the ferrite materials and discuss the Faraday rotations. So that question also can be separate. Apart from this, we'll have separate question for the circulators and separate question for the isolators, like explain or describe. So it having phase shifters. So how we are going to obtain the phase shift here? So for that, this ferrite is placed in the rectangular waveguide, where it is going to be placed where we have DC magnetic field due to the incident wave mode. Okay. And here we have circularly polarized. Like we have different types of the polarization. So here we have circular polarization. So this ferrite materials or that thin slate is being placed where we have DC magnetic field. DC magnetic field have what? Incident wave. Okay, that wave is what? Circularly polarized. So what is the ferrite? Okay, so ferrite is the family of MEO, that is the metal oxide, into Fe2O3. F is the iron, O is the oxygen that you know, and Me represent the divalent iron metal. And it is the nonlinear material. So this ferrite is the nonlinear materials. So now what is the Faraday rotation? So if you are going to keep a piece of ferrite, okay, so where we are going to keep the piece of ferrites inside that circulators or in the isolators. So it is being affected by the DC magnetic field. Then those unpaired electrons of ferrite materials is going to line up with the DC field because of their magnetic dipole moment. So dipole moment, you know, in general, what is the dipole? We have separation of this positive charge carriers one side, negative charge carriers one side. That we are talking in electrostatics, like negative charge and positive charges are being separated by some distance, that is called as the dipole. And when field is applied, suppose electric field is applied, then this positive charge is being aligned in the direction of the electric field and negative charge will be opposite of that. So due to this DC field, unpaired electrons are being lined up. Okay. Now we are going to find the, since we are talking about the magnetic dipole moment here, so we have discussion about the permeability and we have flux density. So here B equal to mu cap H, where mu cap is the mu naught 1 plus, this is the susceptibility that we also call it the chi m cap. So this mu naught is the permeability of the Fourier space, and this chi m cap is the matrix chi m jk. 0 is the one column, again we have jk chi m 0, and this third column is all elements are 0. So first one, this is a chi m cap is what? It is the tensor magnetic susceptibility, and simply this chi is the diagonal susceptibility and k is the off diagonal susceptibility. So this is important to explain about the Faraday rotation. So now, due to this non-reciprocal properties and of unpaired electrons, this ferrite caused some relative permeabilities. So since we have unpaired electrons, now due to the presence of magnetic field, okay, it is going to be have some relative permeabilities. So that is given as mu r plus and mu r minus. So it should be equal and wave is circularly polarized. In that condition only, it will have relative permeabilities. So now we have propagation constant. So for what? Linearly polarized wave. Okay, inside the ferrite. So now we are talking about this here, linearly polarized wave where inside the ferrites. So that is the gamma plus minus equal to j omega root under epsilon mu naught into mu plus k. So mu is what here? 1 plus chi m cap and mu r plus will have mu plus k and mu r minus will be the mu minus k. So finally, the relative permeability that mu are going to change with the applied DC magnetic field. As per the strength of the DC magnetic field, it is going to change. So this mu r plus minus, this is the expression of the equation number 8, where gamma is the gyromagnetic ratio of an electron, m is the saturation magnetization, omega is the angular frequency, as this is the DC magnetic field, and mu r plus is the relative permeability in the clockwise direction, or we have right, okay, and mu r minus is the relative permeability in the counterclockwise, so that can be the either left or negative of the circular polarization. So again, what is the gyromagnetic resonance? So we have omega equal to modulus of gamma E into HDC, that is the DC magnetic field. Then mu r plus is going to become the infinite. So this is called as the gyromagnetic resonance of the ferrite. So already we have seen that in case of resonance, like just generally if you talk about the resonance, so what we have condition will have omega L equal to 1 by omega c. So here what is the condition? Mu r minus is equal to mu r plus. Then resonance is going to occur. Now if mu r plus is much larger in compared to mu r minus, okay, then what is going to happen? Then ferrite is rotated in the clockwise direction. This is positive. So rotation in the clockwise direction. Now here in this situation, we have phase constant, that is the beta plus, okay. So that is going to different from the beta minus. So beta plus in the forward direction, beta minus is when in the backward direction. So finally omega equal to beta plus minus beta minus into L, that is a pi by 2. So this is the different situation when we have mu r plus minus, okay, with correspond to DC magnetic field graph is drawn here. So it shows that axial propagation of the mu r versus SDC. So now finally we are going to see about the microwave circulators. Those part was about only Ferrite materials and Faraday rotation. So here in the microwave circulators, we can have n numbers, okay, but here we are going to consider 4-port circulators. So it is a multi-port waveguide junction in which we can have flow from the nth port to n plus 1 th port. Means from, suppose we are talking about port 1, it will transfer from the port 1 to port 2 only. It will not go from the port 1 to port 3. Okay. So from the nth to n plus 1 th port only, it will have direct, that is the flow will be, and that flow will be in only one direction. Reverse is not possible. Okay. Like from 2 to 1, it will not come. From 2 to, it will go 3. So we have taken here 4-port microwave circulators. That is the combination of two 3 decibel side hole directional couplers. So already we have seen the about 2 hole directional couplers. So here loss is considered as the 3 dB. Okay. So now here in this, if you will observe, it can transfer from the port 1 to port 2, again from the port 2 to port 3, and 3 to 4, and 4 to 1, and so on. Okay. So now we'll see how this directional coupler is going to work. That is the important here. So here we have 2 hole directional couplers. So one coupler 1 is here and coupler 2 is second one. Now, like directional coupler, this is the primary waveguide and another is the secondary waveguide, and 4 port 1, port 3, port 2, port 4. So now how this phase shifter is going to work here. In the primary waveguide, if it is going to move from the left to right, phase shift is 180 degree, and right to left is the phase shift is the 90 degree. And when it is going to cross the hole, then phase shift is the 90 degree. Okay. Here in the coupler 1 as well as coupler 2 also, phase shift is the 90 degree in the hole. Whereas if it is going through the secondary waveguide, so in the secondary guide, left to right, phase shift is 0, and right to left, phase shift is the 90 degree. This is the basic principle on which it is going to work. So now in this, if you see that situation, how it is going to work. So first, if you consider about this port 1, it is going through the primary waveguide alone. So from the primary waveguide, it is going to pass through this. So phase shift of 180 is going to occur. Okay. And finally here, we have phase shift of 180 degree. Now it is going through the primary waveguide to the coupler 1. So primary waveguide to the coupler 1, what will happen here? Phase shift of the 90 degrees is going to occur. And again, from this, in the secondary waveguide, left to right, phase shift is 0. Okay, so finally still we have only 90 degree phase shift. Now from the secondary waveguide, it is going to the primary waveguide, so phase shift of the 90 degree. So again, we have phase shift of 180 degree. So in this situation, both having phase shift same, okay, 180 degree, 180 degree. So here transmission is possible from the port 1 to port 2. Whereas in case of second situation, what we are saying, if wave is going to pass from the primary waveguide, so the coupler 1 to the port 3. So here we will have phase shift how much? 90 degree. So same 90 degree phase shift is going to occur till now, and here left to right in the secondary waveguide, phase shift is 0. So finally is going to appear at port 4 with phase shift of 90 degree. Now if you see the another path, it's starting from the port 1, crossing the coupler 1. Now here phase shift is how much? 180 degree. So now it has phase shift of 180 degree. Okay. And after this, from the coupler 2, it is going through this hole. So phase shift of the 90 degree. So 180 plus 90, 270. So finally it has phase shift of 270 here, 180 due to phase shifter here, and 90 degree in the hole. So total phase shift how much? 270. And previous having phase shift of 90 degree. So now both having phase shift of how much? 180 degree. So here at port 4, it is being cancelled. So that transmission is not possible from the port 1 to port 4. So that's why we have written the transmission will be from the NF port 2 N plus 1 port only. Okay. So this is the basic principle how waveguide this is going to work along with the phase shift in case of circulators, and it is seen as the combination of these two directional couplers. Okay. So same thing here. If you see that that operation is written here. Okay. So each of two 3 dB couplers introduced. So that couplers, right? How it is working in the directional couplers. Here also we have couplers, coupler 1, coupler 2. and it having particular phase shift when it is going to pass through the hose, that is the 90 degree. Okay, and these two phase shifters going to produce the certain amount of the phase shift that we have seen. So in the first situation, what we have explained, primary waveguide 2 through the port 2. Okay, now here phase shift how much? 180 degree going to occur. Again we have coupler 1. Okay, again secondary waveguide. So here we have phase shifter and coupler 2, finally port 2. So here phase shift is 180 degree. So now both having same phase. Okay, so transmission occurs. In the second situation, primary waveguide 2, phase shifter, again coupler 2 and port 4. So phase shift was 270 degree. So we have seen that it is going like this. Okay. Now another path is coupler 1. So here we have 90 degree phase shift. Okay. And going through the secondary waveguide. So left to right secondary waveguide 0 phase shift and appearing at port 4. So 90 degree phase shift. So total phase shift how much? 180 degree. Okay. So that's why it's not possible to transfer from the port 1 to port 4. So now in general, this expression can be written as we have omega 1 minus omega 3, that is the 2m plus 1 into pi radian per second. And omega 2 minus omega 4 is what? 2n pi radian per second. So what is mn value? It can be any integer, even it can be 0 also. So in the same way, we can say that incident wave from the port 2 is not going to emerge to the port 4, it will emerge from 2 to 3 only. Again 3 to 4. So that is the sequence in case of 4 port circulators, 1 to 2, 2 to 3, 3 to 4, 4 to 1. So this was the discussion how 4-port circulator was working. Now this 4-port circulators, here it is being designed with the help of 2 magic T as well as 1 phase shifter is utilized, and this phase shifter is going to provide the constant phase shift, that is the 180 degree. So now here we'll see that how this is going to work. So in the magic T, okay, so this is the going to E plane. This is going to about the H plane part. Again here E, this is the H. So you have concept that in case of E plane T, so if you are going to transmit from the port 3, okay, in case of E plane T, so it is going to appear at the port 1, 2, that is the collinear arm. So that having phase shift of 180 degree, okay, same magnitude, but phase shift is 180 degree. Whereas in case of H plane T, if it is being transmitted from the port 3, then it is going to appear equally in magnitude at port 1 and port 2, that is the collinear arm, without the phase shift. So that is the difference between E plane T and H plane T in terms of transmission. Apart from this, you know about the direction of electric field and magnetic field. Now suppose, for example, here it is given to the port 1. So port 1 is what here? Magnetic field. So now what will happen? In the collinear arms, it is going to appear without the phase shift. So same information we are going to get here, okay, in this collinear arm also, okay. And from this again, this is the as plenty parts. So again, phase shift is not going to occur, okay. So same, it is going to appear from the 1 to 2, okay. Now, if you see here, same signal is going to pass through this port also, this collinear arm. So now it is going through the 180 degree phase shift. Okay. So after 180 degree phase shift, now it will insert here in this collinear arm and it is coming out from the port 3, that is the E plane T. So again, you will have phase shift of 180 degree here. So previous 180 degree and now 180 degree. So total phase shift is what? 360 degree, that is the 0 degree. So that information from the 2 to 3 is transmitted. Okay. First we have seen 1 to 2. Now input was given to the 2. So it is the given to the H plane T. So if you are given to the 2, it is equally in magnitude and phase at the both collinear arms, and same signal is coming to the phase shift of 180 degree. Again, it is coming here to this collinear arms and having phase shift of 180 degree when it is coming to the side arm of the E plane T. So total phase shift 360 degree. So transmission takes place from the 2 to 3. So like this we can understand again from the 3 to 4 how it is going to occurs. Like if you give in the 3, okay. So now again it will have phase shift of 180 degree here, automatic phase shift it is going to give here 180 degree. And again finally this is going to come here to this collinear arms, and again it is going to pass through the phase shift of 180 degree. Okay, so total phase shift is what, 360 degree. So it is able to transfer from the 3 to 4. Whereas if it is coming to collinear arm here from the 3, so already it has phase shift of 180 degree and it is going to appear at port 2 with the phase shift of 180 degree. So this is being cancelled out here. So phase shift should be 0 degree or 360 degree, then only transmission possible. Okay, so like this we can understand. So in case of 4-port circulators, all these 4 ports are matched properly and it is the lossless, non-reciprocals. So all diagonal elements are going to become 0. It is 4 ports, so size is 4 cross 4. Okay, that is the 16. So again, we will use the 0 property of this. 0 property says what? That you are aware of this one element of one column and conjugate of the another column elements. Okay, where 0 is not possible. Otherwise, you multiply like this with this will become 0. Okay, so here possibility you have to see on the basis of that we're going to multiply and add, that is going to become 0. Whereas we have unity property means element of one column is being multiplied with the conjugate of the element of the same column and it is being added, that is going to be equal to 1. On the basis of that, this 13 is going to give us the S matrix of the circulators. Now another is isolators. Okay, so isolator is what? It is also a non-reciprocal transmission device. Okay, so it is used to isolate one component, okay, from the others. So it is going to absorb the reflected wave. So in the test bench, if you see that it is used to protect the keystone mount or a magnetron. Okay, so it is a uniline. Transmission is possible only in one direction, and that is the lossless transmission line. It is protecting microwave generators like klystrons or magnetrons, and it is always placed between generator and loads. So how we are going to, you can construct the isolators by using circulators also by terminating port 3 and 4. Since only 2 ports are required here, so port 3 and 4 can be terminated with proper matched loads. Other thing is that we have to use the ferrite rods in between along the axis of rectangular waveguides. So that is based upon the principle of Faraday rotation that we have seen when it is placed in the DC magnetic fields. So basically now we can see how it is going to work by the concept of if you are going to use the ferrite materials. So it consists of 2 resistive cards. One is the input resistive cards, that is in the YZ plane, and output resistive card is the displaced by the 45 degree in compared to input resistive card. So now this longitudinal applied DC magnetic field having capacity to rotate the wave plane of polarization by the 45 degree when it is going to pass through this Faraday rotation. So that degree of rotation already we have seen is depend upon the applied magnetic field. So here, if you see in this part, we have here input waveguide and this that is we have resistive card. This is input resistive cards. Another is the output resistive cards. Okay. So this incoming wave is the perpendicular to the resistive card. So it is going to pass. Okay. And here after that it has rotation of the 45 degree here by the Faraday rotation. So 45 degree rotation is going to occur here. And this output resistive card is also at the 45 degree in compared to input resistive card. So finally, still this wave is perpendicular to the output resistive card also, and it is going to appear here at the output waveguide. But when it is going to return, so that reflected wave is being absorbed, it's going to become parallel. Since that is wave is what? 90 degree. Okay, that is the perpendicular. Now it will have phase shift of 45 degree. Since here this ferrite rod is that is the material is already rotated by 45 degree. Another rotation that will achieve here in rotation of here in the ferrite rod, the total will be 90 degree. So it was 90, another 90. So it's become what? 180. So now it is going to become parallel. So due to parallel, it will be absorbed here. So that thing is written here. Okay. So we have TE10. That is the already you are aware of TEMN. And here TE10 is called as the dominant modes. So it is perpendicular to the input resistors. So it is going to pass without any attenuation through the ferrite rod. And here this wave in the Faraday rod having rotation of the 45 degree in the clockwise, and that is the perpendicular to the output resistive card. Since output resistive card is also 45 degree rotated with input resistive cards, so it's still that is being cancelled out here 45 45. So finally remain the same perpendicular, and so a result of rotation wave arrives where at the output in without any attenuation. If Faraday is not going to provide this 45 degree rotation, then it will have some phase will be there, so some part will be attenuated. Whereas the reflected wave is going to be becoming parallel to the input resistive card that we have seen. Okay, that output resistive card having 45 degree already. And again, this will provide the 45 in the same direction. So total will be 90 degree. So that will become parallel. So here 1 dB insertion loss is in forward transmission, and we have 20 to 30 dB isolation in the reverse attenuation. So only one direction transmission is possible from the left to right, from the generator to load, and from the load to generator is not possible. So any doubt is there, please write in the comment box, like, share and subscribe. Thank you very much.